Good day, I am Nirajoyce P. Frondoso from BSC2. Today, I will be solving some board exam problems related to equilibrium of forces, determinacy of structures, stresses, and frictions. The first one is equilibrium of forces. Problem 1. The beam holds 3 cylinders, each weighing 1,200 Newton. The diameter of each cylinder is 600 mm. Assume frictionless surface. Determine the reaction at point A. So first, we need to separate the top cylinder. Then label the known values, which is 1,200 Newton. Since our triangle is equilateral, the angle should be 180 degrees. So first, we need to the summation of fx is equal to 0. Then to find the RA, our equation is RA cosine our angle, which is 60 degree, minus RB cosine our angle 60 degree is equal to 0. Since we have like terms and our operation is subtraction, cosine 60 degree and minus cosine 60 degree can be cancelled. So, RA minus RB is equal to 0. Then to find the RA, we need to transpose the negative RB. So, it will become RA is equal to RB. Then next is summation of Fy is equal to 0. Then, our equation is RA sine the angle, which is 60 degree, plus RB sine angle 60 degree, minus our weight, which is 1,200 Newton, is equal to 0. Since RA is equal to RB, we can change the RB into RA. So, RA sine 60 degree plus RA sine 60 degree is also equal to 2RA sine 60 degree. So, 2RA sine 60 degree minus 1,200 Newton is equal to 0. Since we're finding the value of RA, we need to transpose the negative 1,200 Newton. So, 2RA sine 60 degree is equal to 1,200 Newton. Then, to cancel out, we need to divide both sides to 2 sine 60 degree. So, it will become RA is equal to 1,200 Newton over 2 sine 60 degree, which is also equal to 692.820 Newton. So, the final answer is RA is equal to 692.820 Newton. Problem 2. The beam shown is hinged at left end and supported by flexible cable at right end. Determine A. The tension in the cable. First, we need to get the moment from A. So, summation of moment A is equal to 0, which where clockwise is positive. So, 260, which is our force, times 12 over the square root of 12 squared plus 5 squared, which is 13, times the distance, which is 6, minus TBC sine the degree, which is 30 degree, times the distance from A to B, which is 10, is equal to 0. Then TBC is equal to 260 times 12 over 13 times 6 over 10 sine 30, which is also equal to 288 Newton. So, the final answer is TBC is equal to 288 Newton tension. B. The reaction of support at A. Since we're finding the reaction of support at A, we need the forces vertical. So, summation of forces vertical is equal to 0. Then, RAV plus 288 Newton, which our TBC, sine the degree 30 degree, minus 260 times 12 over 13 is equal to 0. So, our RAB is equal to 96 Newton. Next is determinacy of structures. Problem 1. Identify the degree of indeterminacy of the continuous beam. The beam has fixed and two rollers. Remember that fixed has 3 external reaction and roller has 1 external reaction. So 1 plus 1 plus 3 is equal to 5. So our reaction is equal to 5. Then we need to get the E. So E is equal to 3 plus EC. Our EC is 0 since we don't have internal force. So 3 plus 0 is equal to 3. So R is greater than E. Then to get the degree, we need to subtract the R and E. So R minus E, which is also equal to 5 minus 3. So 5 minus 3 is 2. So the final answer is D is equal to 2 degree, stable, and indeterminate. Problem 2. Identify the degree of indeterminacy of the frame. So to get the reaction, we need to use the formula Rex plus 3m. So Rex is 3 because we have 1 hinge and 1 roller. Hinge has 2 external force and roller has 1 external force. So 2 plus 1 is 3 plus 3 and our members, which is 6. And our members, which is 6, 1, 2, 3, 4, 5, 6. So 3 plus 3 times 6 is equal to 21. Then for E is equal to 3 plus EC. So 3 times J, which is joint. So we have 1, 2, 3, 4, 5, 6. We have 6 joints. So 3 times 6 and our EC is 0 since we don't have internal force. So 3 times 6 is 18. So R is greater than E. So to get the degree, we need to use the formula R minus E. Our R is 21 and E is 18. So 21 minus 18 is 3. So the final answer is degree is equal to 3 degree, stable, and indeterminate. Next is trusses. Problem 1. The truss is loaded as shown in the figure. Given the following data, S is equal to 1.5 meter, H is equal to 3 meters, wind loading acting normal to the roof, P1 is equal to 13 kN, P2 is equal to 6.5 kN. A. What is the reaction at A? First, we need to get the forces of vertical and horizontal. So Fy is equal to 52, which is the summation of all the forces, which is 6.5, 13, 13, plus 13, plus 6.5, times 2 over square root of 5 is equal to 46.51. Then for Fx is equal to 52 times 1 times square root of 5, which is equal to 23.26. Then summation of moment B is equal to 0, where clockwise is positive. So RA times the distance, which is 12, plus 23.26, which is our Fx, times the distance 1.5, minus our Fy, which is 46.51, and the distance 9, which is equal to 0. So RA is equal to 31.375 kN. B. What is the horizontal reaction at B? The horizontal reaction at B is negative BH plus our Fx, which is 23.26. Since we're finding the reaction at B, we need to transpose the BH. So it will become positive. So BH is equal to 23.26 kilonewton. Problem 2. A fixed roof truss is used for a residential building and loaded as shown. If P is equal to 85 kilonewton, find the force in member BC neglecting H1, H2, and H3. Remember that the reaction of A is also equal to G vertical, which is also equal to 42.5 kilonewton. So, to get the BC, our equation is 42.5 times the distance, which is 3, minus BC times 1.5 over 4.743 times the distance 3 is equal to 0, which is also equal to 134.385 kilonewton. So the final answer is BC is equal to 134.385 kilonewton compression. Then last is friction. Problem 1. A 120 kilogram man crosses the 4-meter long beam as shown in the figure. The coefficients of static friction at A and B are 0.40 and 0.25 respectively. The beam weighs 50 kg and the theta is 30 degree. Considering the weight of the beam, determine the value of x in meter when the beam starts to slide. So first, we need to get the weight of the man, which is 120 kg times the gravity, which is 9.81, is equal to 1177.2 Newton. Then for the weight of beam, 50 kg times the gravity, which is 9.81, so it is equal to 490.5 Newton. So the summation of FH is equal to 0. Then NA sine the degree, which is 30, minus the friction at A, which is 0.40, NA cosine the degree 30, minus 0.25, which is the friction at B, and B is equal to 0. So NA is equal to 1.628 NB. For vertical, NA cosine 30 minus cosine 30 plus 0.4 NA sine 30 plus NB. So the summation of MA is equal to 0. So 490.5 times 2, which is the distance, then the 490.5 is the weight of the beam, plus the weight of the man, which is 1177.2 times the distance 4 minus the unknown, which is x, minus 609.66, and the distance 4 is equal to 0. So x is equal to 2.76 meter. Problem 2. Determine the minimum horizontal force P required to hold the 150 kg block shown. The coefficient of friction between the block and the inclined plane is 0.45 and the angle is 30 degree. So first is we need to multiply the 150 kg to the gravity, which is 9.81. So 150 times 9.81 is 1471.5. And then our mu is 0.45. And our angle is 30 degree. So our equation is P is equal to M times G times sine theta minus mu cosine theta over cosine theta plus mu sine theta. Then substitute the values. So mass times gravity is equal to 1471.5 Newton. Then sine the degree, which is 30 degree, minus the mu, which is 0.45 cosine the degree 30 degree over cosine 30 degree plus 0.45 sine 30, which is equal to 148.7 Newton. So the final answer is P is equal to 148.7 Newton.